today's lecture, we're going to see multiplication of a matrix by a scalar. This will be our first topic, and the second topic, which will be the main topic, is the multiplication of matrices. So, multiplication of matrix by a scalar. Let's understand this with the help of a equation. So, given A is equals to 1, 2, minus 3, 3, minus 2, 3. B is equals to minus 2, minus 1, 1, 2. And C is equals to 0, 3, 2, minus 1. Find A plus 2B minus 3C. So solution, what we need to do is we need to find A plus 2B minus 3C. So A is our 1, 2, minus 2, 3, plus 2 into B is our minus 2, minus 1, 1, 2, minus 3 into C we have 0, 3, 2, minus 1. So we get 1, 2, minus 2, 3, plus what happens is when we multiply by a scalar, a matrix, this scalar will multiply each and every term in this matrix. So the result will become minus 4, minus 2, 2 ones are 2, 2 twos are 4. It will multiply each and every term. Minus, like here, 3 will multiply each and every term. So first 3 into 0 is 0, 3 into 3, 9, 3 to 6, 3 into minus 1 is minus 3. Now we'll add, so we have 1 plus minus 4 minus 0, and we have 1, 2 plus minus 2 minus 9, and minus 2 plus 2 minus 6, and 3 plus 4 minus 3. So 1 plus into minus is minus, 1 minus 4 is minus 3, 2 minus 2 0, minus 9, minus 2 plus 2 cancels off, we have minus 6, and in the end we have 3 plus 4 is 7, 7 minus into minus plus, so 7 plus 3 is 10. So this is our solution. Another question relating to the same. Say we are given matrix A is equals to 5 minus 3 and matrix B is equals to minus 1, 7. Find matrix X such that A plus 2x is equals to B. So in solution, we'll start with what we are given, A plus 2x is equals to B. From here we have 2x is equals to plus A goes that side minus A, so B minus A, which implies x equals to half of B minus A. So this will become half of B is our matrix minus 1, 7, minus A is our matrix 5 minus 3, which is equals to half of minus 1 minus 5, 7 minus 3. So which is half of minus 6 and 7 plus 3 becomes 10. So what will happen is half will multiply each and every term. So half into minus 6 we have minus 3, and half into 10 we have 5. So this is our matrix X. This half is multiplied by minus 6. So minus 6 into half is minus 6 by 2. Minus 6 by 2 is minus 3. And half into 10 is 5. Okay. Now coming to our second and the most important topic in this chapter, we have multiplication of matrices. Okay. A multiplication of matrices also we are going to learn by the help of some examples. Say if A is equals to minus 2, 3, 4, 1 and B is equals to 1, 2, 3, 4, 1, 2, 3, 5. Find AB. Second part BA, and third part is AB is equals to BA question mark. What conclusion? Can you draw from the result? Solution. So first part, what we need to do is we need to multiply matrix A and B. So first we write matrix A 3, 4, 1 and matrix B 1, 2, 3 and 5. So while multiplying two matrices, to get the element of first row, first column, this is the first row and first column. To get this element, what we are going to do is we will multiply the first row with the first column of the next matrix. First row of the first matrix into the first column of the second matrix. So first row into first column. So minus 2 into 1 plus 3 into 3. Now to get the first row, second column, will multiply. This is the first row, second column. So to get first row, second column, we'll multiply the first row with the second column. So minus 2 into 2 plus 3 into 5. First row into second column. To get the second row, first column, we'll multiply the second row with the first column. So 4 into 1, 4 into 1 plus 1 into 3. Now to get the second row, second column, we'll multiply the second row with the second column here. So 4 into 2 plus 1 into 5. So we get minus 2 plus 9. This is minus 4 plus 15, 4 plus 3 and 8 plus 5. This becomes minus 2 plus 9 is 7, 15 minus 4 is 11, 4 plus 3 7 and 8 plus 5 13. So this is our AB. Second part, we need to find BA. So in BA we'll write B first, 1, 2, 3, 5 and then A. A is minus 2, 3, 4, 1. In a similar way, what we'll do is to get the first row, first column, we'll multiply the first row with the first column. 1 into minus 2 plus 2 into 4. First row, second column, first row with the second column. So 1 into 3 plus 2 into 1. Now second row, first column. So second row, first column, 3 into minus 2 plus second row, first column, 5 into 4. Now to get the second row, second column, we'll multiply the second row with the second column. So 3 into 3 plus 5 into 1. So we get minus 2 plus 4 to the 8, 3 into minus 2 is minus 6 plus 5, 4, 20, 3 plus 2 and 9 plus 5. So we get 8 minus 2 is 6, 3 plus 2 5, 20 minus 6 is 14 and 9 plus 5 is also 14. So as we can see, AB is 7, 11, 7, 13 and BA is 6, 5, 14, 14. So they do not match. So for the third part, we'll write no, AB is not equals to BA. And what conclusion that we draw from here is that matrix multiplication is not commutative. Next question. Let A equals to minus 3, 3, 2, minus 2 and B is equals to 4, 6, 4, 6. Find matrix AB. Write the conclusion if any that you can draw from the result obtained. Solution. So AB will be equals to first A minus 3, 3, 2, minus 2 and then B we have 4, 6, 4, 6. So what we are going to do to get the first row, first column, this first element, we will multiply the first row with the first column. So minus 3 into 4 plus 3 into 4. Then first row, second column, first row with the second column, minus 3 into 6 plus 3 into 6. Then for second row, first column, second row, first column. So 2 into 4 plus minus 2 into 4. This is second row, second column. So second row with the second column. So 2 into 6 plus minus 2 into 6. So we have minus 12 plus 12. Minus 18 plus 18, 8 minus 8 and 12 minus 12. So what we get is 0, 0, 0, 0. So what conclusion that we draw from this is that product of two non-zero matrices can give a zero matrix. Zero matrix is a matrix where all the elements are zero. Okay, this is our solution. We'll also note one more thing over here. If A equals to 0 or B is equals to 0, and then we'll have AB equals to 0 and this will also be equals to BA. If any one of the matrix is a null matrix, then the multiplication of these two matrices will become a null matrix. But it may happen that both of them are not 0 but the product is 0, like in this case. Both of them are not null matrix but the multiplication of two matrices we get as the null matrix. But if any one would have been 0, then the product would have definitely been 0. Like in this case, if A is 0 or B is 0, any one of them is 0, then the product of the matrices will definitely be 0 matrix. Next question. If A is equals to 4 minus 4 minus 3, 3, B is equals to 6, 5, 3, 0, and C is equals to 2, 3, minus 1, minus 2. Show that AB is equals to AC. Write the conclusion. If any, that you can draw. From the result obtained. So AB is equals to 4 minus 3, 3 into 6, 5, 3, 0. So this becomes first row into the first column, 4 into 6 plus minus 4 into 3. First row into second column, so 4 into 5 plus minus 4 into 0. Second row, first column, minus 3 into 6 plus 3 into 3. And second row, second column, minus 3 into 5 plus 3 into 0. So we have 6 4s are 24 minus 4 3 12, 5 4 20 plus 0. Here we have 6 3 minus 18 plus 3 3 9 and minus 15 plus 0, which gives us 12, 20, minus 9 and minus 15. And now we'll find AC. AC will be equals to, our matrix A is 4 minus 4 minus 3, 3. 4 minus 4 minus 3, 3. And the matrix C is 2, 3, 1 minus 2. 2, 3, 1 minus 2. Okay. So what we get is first row, first column. So 4 into 2 plus minus 4 into 1. 4 into 3 plus minus 4 into minus 2. Minus 3 into 2 plus 3 into 1. Second row, first column. And second row, second column. Minus 3 into 3 plus 3 into minus 2. So we get 8 minus 4, 12 minus 8. Okay, this is a minus 1. I mistakenly took this as 1. This was supposed to be minus 1. So this will be minus 1. This will be minus 1. Minus 3 into 2 plus 3 into minus 1. So this will be 4 to the 8 plus minus 4 into minus 1 will become plus 4. And 4 3 12. 12 minus minus plus, so 12 plus 8. Minus 3 into 2 is minus 6, minus 3, minus 9, minus 6. So we have 12, 20, minus 9, minus 15. So if you look over here, AB is 12, 20, minus 9, 15. And AC is also 12, 20, minus 9, minus 15. Therefore, AB is equals to AC. So what conclusion can we draw is that conclusion AB equals to AC does not imply that B equals to C. That is, cancellation law does not hold in general. So as AB equals to AC does not imply B equals to C, so cancellation law does not hold. Number 6. If A is equals to 2 minus 1 minus 1 3, evaluate A square minus 3A plus 2I, where I is a unit matrix of order 2. Okay, what is a unit matrix? We discussed in the previous class that a unit matrix additive identity, not additive identity, in types of matrices we discussed unit or identity matrix. This is a square matrix with all the elements as 0 except for the principal diagonal, whose all the elements have value 1. So 2 cross 2 matrix will look like this: 1 0 0 1. This is an identity matrix. So solution. So first let's find A square. A square will be equals to 2 minus 1 minus 1 3 into A itself, that is 2 minus 1 minus 1 3. So that is equals to 2 into 2 plus minus 1 into minus 1. Then first row second column, so 2 into minus 1 plus minus 1 into 3. Second row first column, minus 1 into 2 plus 3 into minus 1. And second row second column, minus 1 into minus 1 plus 3 into 3. So we get 4 plus 1 minus 2 minus 3 minus 2 minus 3 and 1 plus 9. That is, we get 5 minus 5 minus 5 and 10. So A square minus 3A plus 2I will be equals to 5 minus 5 minus 5 10 minus 3 into A is 2 minus 1 minus 1 3 plus 2 into I is 1 0 0 1. So what we get is 5 minus 5 minus 5 10 minus, so this is multiplication of scalar by a matrix by a scalar. So 3 to 6, 3 into minus 1 is minus 3, 3 into minus 1 is minus 3, and 3 into 3 is 9, plus 2 into 1 2, 2 0 0, 2 0 0, 2 1s are 2. We'll multiply the scalar with each and every element of the matrix. So we get 5 minus 6 plus 2, 5 minus 5 minus of minus 3 plus 0 minus 5 minus minus 3 plus 0 and 10 minus 9 plus 2. So our final matrix is 5 plus 2 is 7, 7 minus 6 1, minus 5, this is plus 3, minus 5 plus 3 is minus 2, minus 5, this is again plus 3, minus 5 plus 3 will become minus 2, and 10 plus 2 12, 12 minus 9 is 3. So this is our value of A square minus 3A plus 2I. Okay. Now we have seen when multiplication for matrices of the same order. Here all the matrices had the same order, that was 2 cross 2. Now if if they have different orders, then how do we say that we can multiply two matrices? Assume, say A has order m cross n and B has order n cross p. So what will be the order of C? So first of all, for matrices to become multiplied, the number of columns in A should be equals to the number of rows in B. This is the first criteria that should satisfy. And the final matrix after multiplication, that is C, that we will get will be equals to M cross will have P. So for two matrices to be multiplied, the first matrix is number of columns should be equals to the number of rows in the second matrix, and the final matrix that is produced after multiplication of these two matrices will have the order of the number of rows that was in A into the number of columns that was in B. This is how multiplication of matrices of different order will take place. So number of columns in A, this will be a criteria, should be equals to the number of rows in B. Number 7. If A is equals to 3, 5, 4, minus 2 and B is equals to 2, 4, is the product A, B possible? Give a reason. If yes, find AB. So in this question, first we will see if the number of columns in A matches with the number of rows in B. So A has order 2 cross 2, 2 rows, 2 columns, into B has number of rows 2 into number of columns 1. This is the order of B. So A cross P, in A cross P, the number of rows, number of columns in A and the number of rows in B matches. Number of columns in A is equals to the number of rows in B. So the product AB is possible. Now let's find AB. AB will be equals to 3, 5, 4, minus 2 into 2, 4. So the order of this matrix will become 2 cross 1. So we'll have 2 rows and 1 column. So the resulting matrix will have the order 2 cross 1. So to find the first row, first column, we'll multiply the first row with the first column. So first row with the first column, 3 into 2 plus 5 into 4. And for the second row, first column, we'll multiply the second row with the first column. So 4 into 2 plus minus 2 into 4. So what we get is 3 to 6 plus 5 for 20 and 4 to 8 minus 4 to the 8. So that is 26, 0. So this is our matrix AB. So this is how we multiply two matrices that are not of the same order. This is how we check if they can be multiplied, and the resulting matrix will have the number of rows of A into the number of columns of B. Number 8. If B and C are two matrices such that B is equals to 1, 3, minus 2, 0 and C is equals to 17, 7, minus 4, 8, minus 8. Find matrix M such that Bm is equals to C. So solution, let order of M be A cross B. So therefore B is of order 2 cross 2 into M of order A cross B is equals to C, that is of order 2 cross 2. So from here we get this should match. So therefore A is equals to 2 and this 2 comes over here. So this is 2 and this B goes over here. So B will be also equals to 2. So therefore order of M is 2 cross 2. This is how we find the order of an unknown matrix in multiplication in this way. So let M is equals to, we'll take the matrix as say PQRS. So therefore Bm is equals to C, which implies B is our 1, 3, minus 2, 0 into M is PQRS gives us C, that is 17, 7, minus 4, minus 8. So we have first row into first column P plus 3R, first row into second column, so Q plus 3S, second row into first column, that is minus 2P, 0 into R becomes 0, and second row second column, so minus 2Q, 0 into S becomes 0. So this is equals to 17, 7, minus 4, minus 8. So in this case what happens is that each element will correspond to the respective elements. So this is from equality of matrices, that say first row first column of this one will be equal to the first row first column of this one. So we have P plus 3R is equals to 17, comma, minus 2P is equals to minus 4, comma, Q plus 3S is 7, comma, we have minus 2Q is equals to minus 8. From here we get P equals to 2, minus minus cancels off, which implies Q equals to 4. Now P plus 3R is equals to 17, which implies 2 plus 3R is equals to 17. So hence 3R is equals to 15, which implies R equals to 5, and Q plus 3S equals to 7 implies 4 plus 3S is 7, which implies 3S equals to 7 minus 4, which implies S equals to 3 by 3, which is equals to 1. Therefore the matrix M becomes, M was PQRS. So P is 2, Q is 4, R is 5 and S is 1. So this is our matrix M. And the last question, number 9. Find the matrix M such that M into 3, 6, minus 2, minus 8 is equals to minus 2, 60. Solution, just like we did in this question, we'll again do it in the same way. Let order of matrix M be A cross B. Therefore M, that is order A cross B, into this matrix 3, 6, minus 2, minus 8, that is of order 2 cross 2, is equals to minus 2, 16, that is of order 1 row 2 column, so 1 into 2. So this and this should match first criteria. The number of columns in M should be equals to the number of rows in the second matrix, so B equals to 2, and this goes over here and this comes over here. So 2 and 2 matches, A will be equals to 1. So order of M is 1 cross 2, because this was A cross B, A is 1, B is 2, so order is 1 cross 2. So let M be, we'll take the matrix 1 row 2 columns, so we'll take the matrix as say PQ. You can take XY also, it's not an issue, alphabets are your choice. So therefore PQ into 3, 6, minus 2, minus 8 is equals to minus 2, 16. So which implies first row, first column 3P minus 2Q, first row, second column 6P minus 8Q is equals to minus 2, 16. This is our matrix 1 cross 2. So this implies 3P minus 2Q is equals to minus 2, and by equality of matrices, first row first column equals to first row first column, first row second column equals to first row second column. So 6P minus 8Q is equals to 16. So from here we have 3P minus 2Q equals to minus 2, no changes, and from here we'll take 2 common, so 3P minus 4Q equals to 16, which implies 3P minus 4Q is equals to 8. So let's take this as equation 1, this as equation 2. So equation 1 minus equation 2, we get 3P minus 4Q equals to minus 2Q equals to minus 2, and 3P minus 4Q equals to 8. We are subtracting them, so signs will change. 3P minus 3P gone, minus 2Q plus 4Q is 2Q, minus 2 minus 8 is minus 10. So from here we get Q equals to minus 5. So putting value of Q in 1, so 3P minus 2 into minus 5 equals to minus 2. So this implies 3P plus 10 equals to minus 2, which implies 3P equals to minus 12. From here we get P equals to minus 4. Therefore matrix M is equals to, it was PQ, so P is minus 4 and Q is our minus 5. So this is our matrix. With this we come to the end of this lecture. Please complete all the exercises that is left in your book from the chapter Matrices. Thank you.